Mode extraction, obtaining the modes of an electromagnetic cavity. Part 6, narrowband excitation parameters and narrowband excitation run. Up to now, we have let VSim choose our time step, but now we want to know the time step in the constants and parameters in order to compute the number of steps of the simulation. For that, we have added, prior to this segment, the variables dx, which is the length of a grid cell in x, dy, which is the length of a grid cell in y, and dz, the length of a grid cell in z. From these, we calculate dl, which goes into the computation of the stable time step. In the constants section, up at the top, we define dmfrac, which goes into the stable time step calculation. It is also used below in the surface meshing tolerance. The smaller one chooses dmfrac, the better the surfaces are meshed, but then the smaller is the time step. To make things consistent, we set the surface meshing parameter to dmfrac. Finally, we compute the time step, dt, to be 99% of the stable time step. And we insert that time step into the simulation. Now we have defined a number of constants that will be used in the excitation. The minimum frequency desired in the simulation, 1.1 gigahertz, the maximum frequency, 1.6, the separation between any non-desired modes, 350 megahertz, and a Gauss cutoff, which tells us how well we are separated from any modes of any neighboring frequencies. We've chosen this to be 3 times 10 to the minus 14th. Corresponding to these constants are the parameters down below. For example, num sigma says that to get to 3 times 10 to the minus 14th, we have to go out to almost 8 sigma. From that number, we can calculate what is the standard deviation in frequency and in angular frequency, omega, the corresponding in time. And from that, we know that in order to go, we need to go twice that, ring up and ring down, to get the time after which the simulation can be cut off. And from that, we can calculate the number of steps. In this case, we see it's somewhat less than 24,000 steps for this simulation. So we put those numbers into the elements tree under basic settings. And lastly, we have using this ring band function, which is the function that will ring us up in a narrow frequency band corresponding to the parameters up above. This corresponding space-time function is defined here. We now replace the current to be ring jz rather than ping jz so that we can use this new function. And we'll save this new simulation. We're now ready to run. We add in dump at time 0. We set the dump periodicity to something reasonable like 4,000 steps, and we are ready to go. So we hit the run button. The simulation is now running, and when it is completed, we will come back.